Hello friends, today we will discuss how to find poles and zero, how to find poles and zeros in passive circuits. Okay, uh, so first we will like to know what is poles and what is zero. So suppose we are having some circuit. It is having transfer function hs, so this is bos, this is bis. Okay, this is I'm taking in Laplace. So we are giving input and we are getting vo output, so hs equals to vo by bis. So this is our transfer function, so this is our transfer function. Now for pole, our transfer function for s equals to sp, for pole transfer function become infinity for pole, and for zero our transfer function equals to 0. And one more thing, you can say that our output is infinity, and here output is goes to 0. Here one more thing, in circuit every node in circuit gives one pole. Maybe those are at many poles are at high frequency and non-significant, and only we consider dominant pole which are under UGB. So okay, so this is definition of pole and zeros. And now let's consider first order system or simple circuit. So say this is Z1s, and this is Z2s. Okay, and this is Vi and this is Vo. So this is collective impedance of say some network. This is also collective impedance of some network R and C. Okay, now transfer function for this simple circuit is given by Z2s divided by Z1s plus Z2s, just like resistive divider network. Now when Hs goes to infinity, only when Z1s plus Z2s equals to 0 and Z2s not equals to 0. So it means Z1s equals to minus Z2s. So this is condition for pole. And what is condition for 0? Condition for 0 is basically Vo equals to 0, or you can say Hs equals to 0. This is possible only if Z2s equals to 0 but Z1s not equals to 0. It means this is shorted, this is 0 but this is not, Z1 is not 0. Now another way is that Z1s, this is infinity, so it means there is no connection between Vi and Vo, but Z2s is finite, not equals to infinity. Okay, Z2 can be 0 as well. So this is for condition 0. Now we can also see this in such a way that for pole we can also see in such a way that Hs is VO upon Vi. Now if Vi is 0 and VO is some finite value, then this is also infinity. So it means basically for finding pole we can short our input voltage source to ground so that input is 0. Okay, now output should be finite. So if input is 0, if Vi equals to 0, so I also 0. Now output equals to I, this is input current, say this is I. Now this is 0 when Vi equals to 0. So it means I is Vi equals to I into Z2 or Z out, actually whatever is output impedance, and so this is 0. So for this we need to see if this is 0 and output is finite, and this is finite, actually this is finite. Now output is finite, current is 0, Z out, this is finite, so it means Z out should be equals to infinity. So we need to find out Z out for this circuit. So it means Z1 and Z2 are in parallel. So okay, I will do here. So Z1 and Z2, Z1, Z2 are in parallel, and here Z out. So this equals to infinity. So these are in parallel. So it will be Z out is Z1, Z2, Z1 plus Z2. This should be infinite, means Z1 plus Z2 equals to 0. Z1 equals to minus Z2. So here I am not writing as, just it is understood. I am taking Laplace in Laplace terms. So this is the way how to find actually poles and 0. So now let's do some examples. So example 1, so let's consider this circuit R, C. Here we are giving input Vi, and another part we are doing this. These are RC, this is Vi, this is VO, this is VO. Okay, so now in first example, so what we have seen that there are two ways. So one way is this is Z1, this is Z2. Z1 plus Z2 equals to 0. So R plus 1 by SC equals to 0. So SP equals to minus 1 by RC. So this is one way for finding pole. Now another way is we will short our input. So it will be R parallel C. So R and C are in parallel. So R plus 1 by SC equals to 0. SP equals to minus 1 by RC. Now let's consider this case. Okay, so in this case let's find out whether 0 exists or not. Now one condition for 0 is this is for here pole. Now for 0, what we have to do, we need to find out condition for which Z2 equals to 0, Z1 not equals to 0, Z1 equals to R, so it is not equals to 0, it is finite actually. So now Z2, when Z2 will get 0, so Z2 is 1 by SC. This is 0 only when S is infinity. So 0 is at